Hi, everyone. This morning, let's introduce ourselves to the concept of enzymes and how they work. This is an enzyme. Enzymes are made of proteins, which are large chains of amino acids, and all enzymes have a three-dimensional structure that helps determine their function. Now, remember, the first level of protein structure is primary structure, which is simply the chain of amino acids held together by peptide bonds. Secondary structure includes alpha helixes and beta pleated sheets, which are held together by hydrogen bonds. And then you have the folded protein, the three-dimensional or tertiary structure, where the hydrophilic amino acids tend to be on the surface and the hydrophobic ones are on the interior of the protein, away from the surrounding water in the cell. Now, the business end of an enzyme is called the active site, which is indicated here. The active site is where the substrate binds to the enzyme. Now, for the substrate to bind to the enzyme, it must have a complementary shape to the active site. So here we have a substrate that is complementary in shape to the active site. And this substrate will interact with this enzyme. Okay, but it's more than just shape that determines whether a substrate will bind to an enzyme. Let me show you a similar substrate with the same shape. Now, can anyone tell me what's wrong with this picture? Why this substrate would not bind with that active site? That's right. It's because of the charges on this substrate are incompatible. Remember, like charges repel. So even though the substrate has a compatible shape, because the charges on the R groups of the amino acids in the active site are incompatible with the charges on the substrate, that substrate would not bind. Remember, some amino acids that make up proteins have R groups that have a charge on them. So if there were R groups on amino acids at these locations in the enzyme's active site, it would only bind to that active site would only bind to a substrate that had the compatible shape and compatible charges. So that substrate will bind and interact with the enzyme. Now, enzymes can also be inhibited, and inhibited, of course, means it slows down the rate of the enzyme catalyzed reaction. There are two kinds of inhibitors you need to know about: competitive and non-competitive, or allosteric. Now, competitive inhibitors do exactly what they sound like. They compete with the substrate for the active site. So competitive inhibitors need to have some similarities in shape to the substrate. So here's our substrate. Here is a competitive inhibitor. Now, this competitive inhibitor could slide into the active site like so. And if that competitive inhibitor was bound to the active site, the substrate obviously could not get in. Many pharmaceutical products and drugs are competitive inhibitors. One of the most famous ones we're going to talk about in class is the chemotherapy drug Gleevec, which is a competitive inhibitor of the BCR-ABL enzyme in leukemia cells and has been an absolute game changer in survival rates for chronic myelogenous leukemia. So this is an example of a competitive inhibitor because it competes with the substrate for the active site. Now, one more thing. There is such a thing as a non-competitive inhibitor, which is also called an allosteric inhibitor. You may be wondering what this little divot in the enzyme is. This represents the allosteric site. This is where a non-competitive inhibitor or regulator can bind. Here's our non-competitive inhibitor. Notice it can't really bind with the active site, but here's what it can do. Watch carefully. The non-competitive inhibitor or allosteric inhibitor binds to the allosteric site. And as it binds, what has happened to the shape of the active site? That's right. The shape of the active site has changed so that the substrate can no longer fit. So let's review. Enzymes are made of proteins. Proteins have a three-dimensional or tertiary structure. The place where the enzyme binds to its substrate is called the active site. The active site needs to have a similar shape, a compatible shape or complementary shape to the shape of the substrate. In addition to shape, sometimes the charges on the R groups and the substrate come into play as to whether a substrate will bind to the enzyme or not. Enzymes can be inhibited by competitive inhibitors. Here's a competitive inhibitor. Competitive inhibitors bind to the active site, blocking the substrate. Enzymes can also be inhibited by allosteric or non-competitive inhibitors, which bind to an allosteric site and change the shape of the enzyme so that the substrate can no longer bind. So I hope that makes sense. And let me know if you have any questions. Have a great day. Bye.